All right, we're in part B. We're looking at the inner loop of r equals 4 minus 6 sine theta. And please go ahead and graph for r equals 4 minus 6 sine theta and see what the inner loop looks like, because that's the starting point. Um, and you should be able to have this kind of graph here, okay? So as you see that the inner loop is right here. Okay, so we're going to find the area of this inner loop. Okay, so essentially we're finding the area of this inner loop. Okay, I can even zoom that a little bit. Okay, so what we want to know now is like what theta values sort of like sweep this region. Okay, so because when you graph this by using your calculator, it doesn't really tell you anything about that. Okay, so to be able to figure that out, you should be able to have like a table of sample values and sort of like get some theta values out of that and r values together with that, and then see where you start, where you end to cover that inner loop. All right, let's get the theta and r values. Let's start with theta equals 0. Okay, have your unit circle with you and calculator with you, because we're going to do function evaluation here. So we're looking at 4 minus 6 sine 0. Okay, that's equal to, well, sine 0 is equal to 0, so you should have this to be 4. Okay, so at 0, when the ray is theta equals 0, which is in fact the x-axis, you're walking 4 units. Okay, so that means that I'm ending up right here. So I'm not really even close to one of those like inner loops. Okay. In fact, there's only one inner loop, so I'm still far from that. We should sort of like keep adding points. All right, so why don't we look at pi over 6? Okay, so let's look at pi over 6. So we are talking about this ray here. Okay, at pi over 6, we have the function value to be sine pi over 6 is 1/2. So 6 times 1/2 is 3, so 4 minus 3 is 1. We're looking at 1. So essentially, on this ray here, I'm going to walk 1 unit in the other direction, because this direction is still positive, but we're walking in the opposite direction here. Okay, so essentially, pi over 6 takes you to right here. Okay. So now we are sort of like confused. Are we going in this direction all the way, or going in this direction? So we have to figure that out. All right, so let's look at pi over 8, and we can actually visually observe pi over 8 here. Okay, let me just zoom in right here at pi over 8. What do we have here? Well, at pi over 8, we're hitting this point. Okay, so let me just, because this is the ray corresponding to that, right? So that means I'm hitting that point here. So my direction is here, going with this orientation, okay? So since my sample point was pi over 6, so I don't know what or when the curve hits this origin, okay? So I have to figure that out first. Okay, to be able to see that, we should probably find out for which r we hit 0. Okay, for which r, so that means for which r we hit 0. So you have to solve 4 minus 6 sine theta equals 0. That implies that sine theta equals 2 over 3. Okay? And theta out of this is arc sine 2 over 3. I know that there's an angle, which is arc sine 2 over 3. And when I hit that, I go all the way to 0. Okay, so I'll use a different color here. Okay, so the inner loop starts from arc sine 2 over 3, whatever that is, and then we keep going, right? We keep going because pi over 3 we just got right here. So let me just clean that up, and then here arc sine pi over 3, that's the ray corresponding to that, and this is pi over 3. And we can keep graphing, I think, until we hit pi over 2. Let's see what's going on at pi over 2. Okay, so let's say like I got pi over 2. Let's say this is 4 minus 6 sine pi over 2. Okay. And sine pi over 2 is 1, and 4 minus sine pi over 2 is negative 2. Okay, there we go. Let me just smooth that out. Exactly, okay. So this is negative 2. So when the ray is pi over 2, I'm going to walk 2 units in the opposite direction, so I'm going to hit here. Okay. So essentially, so this point corresponds to theta equals arc sine 2 over 3, and this point here corresponds to theta equals pi over 2. So if I want to sweep through, the half of the inner loop here, okay, so I should run theta starting from arc sine 2 over 3 all the way to pi over 2. And if I get the area of the full loop, then I should multiply that area by 2. Okay, so I'm sorry that this is hard to show to you, and I try my best to show the graph as much as I can, but going back to the area formulation here. So area is 1/2. So we're talking about the one loop, right? Half of the inner loop. So essentially, we're going to multiply that by 2. So 1/2 arc sine 2 over 3 to pi over 2, 4 minus 6 sine theta quantity squared d theta. Okay? That's the area of the full loop. See, like plotting the function itself doesn't help you to figure out the lower and upper limits, so you have to really pay attention and find the right limits to work with, okay? So right now I'm going to integrate this, but let's simplify 2 times 1/2. So in fact, 2 times 1/2 is 1, so I can get rid of this and write the area, the full area of the inner loop with this integral. And I'm going to go ahead and evaluate the indefinite integral version of that right here. Okay, let's expand this out. 16 minus 48 sine theta plus 36 sine squared theta d theta. Okay, and here I'm going to use the power rate using formula again since we have like sine squared theta, and that's the even power of sine. So 16 minus 48 sine theta plus 36 times 1 minus cosine 2 theta over 2 d theta. In fact, that makes this 18 times that. Okay? Right, we can simplify that before we integrate. And now we can integrate 16 theta, this is sine, right? Plus 48 cosine theta, because sine theta is the antiderivative of negative cosine. Okay, plus theta minus 1/2 sine 2 theta plus c. And then you should have 18 also, right? Let me just put the 18 back here. Here we go. We got all sorted out. So I'm going to carry this forward here because I'm going to now evaluate the definite integral based on the antiderivative I got from this part. So 16 theta, 18 theta, that's 34 theta, plus 48 cosine theta minus 1/2 sine 2 theta. And the lower limit is arc sine 2 over 3, and upper limit is pi over 2. Now let me erase the bottom part, and we can continue from there. All right, there is a typo here. Let me just correct that. This should be 9 sine 2 theta. Okay, please correct that. All right, so let's plug in upper limit, 34 pi over 2 plus 48 cosine pi over 2 and minus 9 sine 2 pi over 2, that's sine pi, minus 34 arc sine 2 over 3 plus 48 cosine arc sine 2 over 3 and minus 9 sine 2 arc sine 2 over 3. Okay? Let me just put the bracket the right way. So this is in fact the result of the bracket. And these are zero terms here, obviously, because sine pi is 0 and cosine pi over 2 is 0 as well. And you can go ahead and evaluate those cosine arc sine 2 over 3 and sine 2 arc sine 2 over 3 numerically, and as well as this term here, okay? And you should get approximately 1.7635, okay? So this is you using your calculator and getting this area to be 1.7635. Going back to the original problem here and the graph, is you see that I have this area of the inner loop calculated correctly as 1.7635. Okay. All right, this was already a long video. I'm going to stop it right here. And please continue to part C to see what I'm going to do for part C. And have your TI-84 ready. All right, bye.